All right, so before we start, I kind of realized I don't really market my website very often or ever when I'm making tutorials. So yeah, in case anyone is interested in buying my Houdini training series of, any of the stuff that I've made, you can go to my website, which is rohandalvi.net. And yeah, if you find anything interesting, you can pick it up. Okay, so enough marketing. So in this video we are going to take a look at how to use the procedural noise maps that are available in materialX in Karma. Okay, so I have a very simple setup. I have a grid. I have assigned a material to it, which is I made a materialX subnet. Like there is a ready-made subnet. If you type in subnet, you'll get something called Karma materialX subnet. So that's what I've taken. And I have a dome light. I haven't taken anything in that, so I should probably take like an HDR in there. And then I have Karma. For this lesson, I'm going to use the CPU version for the simple reason that we're going to do displacement. And Karma CPU shows displacement in real time. With XPU, every time you make a change, you have to restart the render. That's still a limitation in the XPU version. So it'll just be easier to do it in CPU, and then in the end you can change it over to XPU. It should pretty much just work. Okay, so to get started, I'll do a couple of things. The first one is we'll come into the materialX subnet, and it has like a ready-made node for displacement, which we'll need later. I don't need the inputs, and I don't need the materialX surface either. What you have to do is just type in standard and you'll get materialX standard surface, and just connect that to the output. And I can just turn on Karma and we should get a basic render, which is this. Okay, so starting off with the noise maps, you get a very limited number. Like you have Voronoi noise, you have standard noise, you have cellular, and cell actually is like squares, and you have Worley noise. And then if you type in fractal, then you get fractal 3D. Okay, so those are like the 4 types of noise maps that you get. Okay, so take the 3D versions of them. We'll take noise 3D and cell 3D, and we'll take Worley 3D. Okay, so just to see what they look like, if we start from top, so that's the fractal noise. Okay, and it comes in like it probably has the most number of options. So you have something called diminish, which gives you like more, I don't know, sort of increases contrast. Like lacunarity gives you more detail. You have number of octaves, so the more you increase it. And then you have amplitude. Okay, so and then you can change it from float to color, or you can have like vector 3. So the color and vector 3 are useful when you're trying to use the noise map to distort other noise maps. So you need like a vector version. Okay, so that's you don't have any controls here. So we'll talk about this in a while of how to control any of this stuff. Okay, so there is no offset or frequency or anything like that. Okay, so first we'll just go through these and then I'll talk about the rest. So this is then you have like Voronoi noise, which we can keep it to float. So you get this. Okay, you have like different types. Okay. Oh yeah, okay. So you get the square, and then you get like standard cells and things like that. And you have like a jitter. So if you make the jitter 0, you get you get them as a grid. Okay, so as you increase it, you'll see like it sort of varies. Okay, then you have like standard noise, which just does this. Okay, like it's mostly like the fractal noise, but without octaves or anything like that. And you can adjust pivot, which kind of lowers contrast between them. And then what else do we have? We have cell noise, which is this, which just generates like blocks. And the same, it just has position. It has like no parameters at all. And then lastly, you have Worley. Okay. So I think instead of using Worley, it's better to use Voronoi noise because it's doing the same thing, except you get more options. So, like you get these things, you have like P1, P2, like these are interesting. Yeah, those two are not doing anything. Will they do anything if I change these? Yeah, I haven't researched this one. Okay, so now the big question that comes up is how do you control the frequency and the offset values for these, or rotation for that matter. So what you need to do is, I'll use this temporarily, or let's just go with fractal. So let's keep this. Okay. So what you want to do is take a position node. You need 4 nodes to do this. And I'll just do one thing. I'll create a new shelf, or yeah, okay. And just to sort of show you what I want to do. Okay, so you take the position, then you take an add node, okay, and you take a multiply node, and you plug all of them together. And what you'll get is, so the add becomes the offset, and the multiply becomes the frequency. Okay, and then lastly, you get, if you type in rotate, you'll get like rotate 3D. Okay, so you can put in rotation. And if you take all 3 of these and then connect this into position, now you have controls. Okay, so what you can do is, if I take the offset and I try to move it, see, you can now move this. Okay, and if you take the frequency and let's say if I make it 5, then you can control frequency. So if I make this like say 2 and 2 and 2, yeah, because the frequency again, so these things give you, like a lot more control over it. See, so I can, like control frequency. And then lastly, you can rotate it. So if you want to rotate this, see, we can rotate it. Like if I make it 45 degrees, see, so you can rotate this. So these 4 combined will give you the controls that you need to control any noise map. So what you can do is, one is you can control this into you can convert this into a subnet and a digital asset. So you can just, use that over and over again. So like you can promote these parameters and do that. I'm not going to do it. If you know Houdini well enough, that's not a problem. And or the other option is you can just take all of this and drag and drop it here. And we can call it as, let's call it noise control. Yeah, and hit accept. And so what we can do is, the next time I want this, I can just click there and it adds, this whole node tree for me, and I can just, plug that in. So it makes life a little easier. So either ways, it's fine. Okay. And the nice thing is that once you add it to a shelf, it also shows up in your tab menu. So I can just type in noise control here and I can get the exact same thing. So this makes your life easier. Okay, so I mean, the lesson is pretty much just that. You can't really, there's nothing else to do here. But the nice thing about materialX is the same thing that made WAPs very powerful, which is the fact that almost any value can be controlled with a map. Okay, so which makes it really useful. Okay, so what I'll do is, let's say if we want to create like a desert. Okay, so that's the simplest thing that I can do right now. Okay, so what I'm going to do is, I'm going to take this, we're going to plug this into displacement. Okay, so we're going to do displacement. Okay, so I'll take this, I'll take all of this, to Control C, Control V, and just plug that into position. Let's keep it to 1. And let's plug this into, let's do one thing. Let's put this through a multiply so we can get like additional control. So this will be my intensity. Even though there is a scale value in here, but let's say if you're trying to mix multiple maps together, it's better to sort of, plug it in through this. So I can just take this and plug it into displacement, and let's disconnect the noise map, and there you go. See, so you have this. Okay, and so what I can do now is, let's say I want to stretch this out a bit. So I'm going to come into frequency, and in the x-axis, let's make it, or in the z-axis, let's make it 0.2 and see what we get. Okay, no, let's keep it in the x. So 0.2, there you go. See, so we have this. Now the next thing I want to do is, let's say like this is all very straight right now. Okay, let's say we want the whole thing to be a little more wavy. So I can take this noise map. Okay, and we'll also control this. So Control C, Control V. And I want to connect this over here. Okay, but like let's lower this intensity. Let's take the frequency down to 0.2. Yeah, so we have something like this. And lower the intensity further. So we have like a wave going through it. And we add these two together. And what that should do is it will give me like those basic waves, but they are now, you know, like this. So I can control that a little bit more. Okay, but the thing that I want is I want these waves to be distorted. So that's where it helps with the fact that, you know, you can sort of modify and distort any which way you want to. You don't need any custom nodes for that. Okay, like with Octane, there is a separate node for distortion. You don't need any of that. Like what you can do is if you just add a noise map to the position, it'll work. Okay, so what I'm going to do is I'm going to take this entire fractal noise, do Control C, Control V, and this is going to add into this position data. Okay, so first of all, this needs to be 3D. So we're going to change it to vector, and I'll plug it in through a multiply. Now, the one change I'm going to make is when you plug it in through a multiply, it's going to change this input 2 into a vector, but I just want like a uniform value. So I'll type in a constant and I'll keep this to 1 for now. And I'll plug the constant in here. So I can then just, you know, this is again like intensity, or let's call this distort amount. Okay. And let's disconnect this temporarily, or I'll make it 0. So I can just see this, and we'll do an add here after the rotation and plug in this, and you'll see that. Okay. Now what I need to do is we need to make some adjustments. So take the intensity and bring it down a fair bit. There you go. Okay. And we can also lower the frequency a bit. Let's try to make it 0.1. Maybe increase that frequency a little bit. We can try to offset it. Yeah, I think we need more frequency. So let's make it 0.3. Yeah, that's not bad. Okay. And we can just lower this so it's like a little wavy. Yeah, there you go. See, so that's nice. And we can try to increase the lacunarity of this. Not too much. Yeah, I think this is okay. Yeah. And you can try to increase the value here. Yeah, just sort of play around with it till you get something that looks nice. If you increase the diminish, you'll see like how much it starts to distort. Yeah, so if we combine these two things together now, if I get this back to 0.2, see, so we have, you know, like dunes like that. Maybe increase this frequency to 0.3. Sorry, 0.3. Yeah, there we go. And lower that a bit. And increase this. Yeah, maybe I want to lower the lacunarity a little more. Yeah, okay. Yeah, that's not bad. Like what we can do in order to like add more detail to it, I can just duplicate all of this. Okay, so like if we want, let's just, let's see if we can label this. This is dunes. And this is, let's call this hills. And then similarly we want, I'm going to take all of this and duplicate it. So let's do Control C, Control V. And this will be, we'll call it small dunes. And let's plug the whole thing in there temporarily. And I'm just going to increase the frequency. Okay, so let's get this to 3. Yeah, and let's get this to 1. I don't think this is a good idea, but we can see what we get. Okay. And what I'll do is I'm going to take the overall intensity and make it really low. So we get this. Okay. Maybe let's make this 2. Okay. And then we can add it all together. So I can take and add again. And this comes in here. We have something. Not the greatest looking thing, but okay, something. Let's lower this further. Yeah, let's just adjust intensities a little bit. Let's make this 0.1. Yeah, just sort of play around with it. Yeah, I don't think I like the secondary noise that's coming in. Or maybe it should be like really, really low. Let's make it 0.1. Yeah, okay, that's not bad. Okay, let's take the dome light and maybe adjust that a little bit. So I can, get a little more sunlight in there. Okay, and then we can try to color this. So let's just take, if you are using Karma CPU, then you have the option to use the curvature map, so that's not a bad idea. So you can just type in curvature. This only works in CPU right now. It doesn't work in XPU. And we'll plug it in through a color ramp. And what you need to do for the curvature map to work is you need to take a position node and a normal node. I think these should be inbuilt, but they're not. Like if you don't connect these, it's not going to work. Okay. And then I can just plug that into base color and you'll get this, okay, which is, wow. Let's try something. It really picks up all the details a little too much. Let's try to increase the lacunarity. Hey, that's not bad. Maybe just a little bit. Yeah, perfect. Okay. And what I can do is I can just give it some basic color. Let's see if we can, let's go -1 to 1. No, 1 to 1 is fine. Let's try to keep it to Gaussian. You get like a couple of varieties on this. Nah, mean is okay. I'll talk about this one later at some other point, but you can just, kind of experiment with this. Yeah, and let's try to give it, like if you come in here and there is something called as sand. So you can just pick up sand. Okay. Not the best thing, but that's not bad. Let's do one. Let's just, do that. And then I can just plug in. That's not looking bad at all, actually. Let's increase this a little bit. Let's try to reverse this, see what we get. That's not bad. We'll just keep it fairly close to each other, so we don't have like, yeah, okay, that looks fine. And then I can just increase or decrease the specular roughness depending. That actually looks like wet mud or something, more than a desert, but maybe that'll look, yeah, there you go. That looks better as a desert. We can also try to do a remap in the middle, see if that helps. So I'm going to plug a remap and let's just see what we can get. If I make this say -1, what do you get? Yeah, I think that's better. It sort of blends it a little bit more. Yeah, I think that's not a bad idea. And we can try to increase the lacunarity a little more. Yeah, not bad. I mean, not the greatest looking thing. I mean, you can do better stuff with height fields, but there is an advantage to doing it this way, is that if I come over to my grid and if I just increase the size of the grid, let's say in the x-axis I make it 15, then it just sort of, you get like infinite, like you get a nice little, you want to do a flyover of dunes or something, this is great. If you want to improve quality of the displacement, come into Karma, and if you come down to geometry and shading, you'll find something called dicing, and that's the quality. Okay, so if I make this like 3, it'll slow down, but then it'll give you better quality. See, the dunes become sharper. I'll just let it render through once. Yeah, but there you go. See, if we had more variety of noise maps, you could do a much better job with this. But yeah, for what it is and what we have right now, it's not bad. What you can also do is you can try to connect this directly into a normal map. So I can take like this entire add node, like this one, and I can type in height to normal, and I can just plug this in over here, and let's see if this works. So we can just plug this into normal, and there you go. So what that does is it helps you add like additional detail. Not a great, it doesn't always work in the best way. Like you can try to lower it a bit. Actually, okay, I don't think it's supposed to work this way. I think we need to plug this in through a normal map. Okay, so take a normal map, and so this comes in here, because this is not defining anything, right? Like all the defining is done here, like what is the normal space and everything, and then plug that in over there, and there you go. That gives you a completely different and as terrible a result. Okay, so we can just like lower the displacement amount now, or the noise amount, how much we want. Yeah, but it'll help you, add a little more additional detail to the whole thing. Probably, I think it still needs work. Anyways, not needed, but yeah, it's something that you can do. Like if I disconnect the displacement, let's see what we get. Just hit restart. Yeah, see, there you go. If I increase this, you should be able to see. Yeah, see, you have like the height, but I think when it combines with displacement, it gets a bit too much. Yeah, it does definitely get a bit too much. Let's try to do one thing. Let's only take the big waves. Yeah, either ways it looks terrible. Anyways, it's an option, you can try it out. Okay, so the next lesson I'll do another example of how you can create something really complex with the 4 noise maps that we have. Okay, so on Twitter I had put up like that beach and cliffs render. So I'll do that for the next video. Okay, that's pretty much it.